I'm also very excited about this presentation, and it's been a long time coming since I'm such a planner. So James, thank you for putting it out on your calendar. I'm pleased to introduce an assistant professor of sustainable packaging at Clemson University. Having a background in chemistry, James completed his PhD studying bio-based and recyclable polymers in the Department of Automotive Engineering at Clemson. Dr. Sternberg's work focuses on redesigning common polymers to increase biocontent, compostability, and recyclability to fit within a circular economy. His work also includes studying life cycle assessment and helping local businesses transition to more sustainable materials through self-auditing and sustainability transition plans. This aligns so well with what we try to do as individuals through our Acts of Green project. And James, we're very pleased to welcome you. Thanks for being here.
Great. Well, thank you for having me. Yeah, this is great to learn a little bit about the Rotary Club and see your guys' is this a monthly meeting or is it a weekly meeting?
We meet every week. Yeah.
Every week. That's great. That's really cool. I'll admit that I don't have much knowledge of the Rotary Club. So this is really, it's good for us too, because we want to get out this program that we have to as many people as possible to hopefully get as many contacts as possible. And there'll be opportunity at the end of this presentation for you to get my contact information and even a little QR code that'll take you to a form that you can fill out if you by chance know any businesses, or even, you know, the place you go to eat every day or every week that maybe you think could benefit from transitioning to some more sustainable to-go containers and cutlery and that kind of thing. So I'll go ahead and share a little PowerPoint put together. I'll try and make this as non-sciencey as possible. It's a little bit hard for me to do. Not that you guys can't handle it, but I know I can kind of get into my own world and leave people out. So as Julie mentioned, I kind of have a background in trying to get this guy to come up. I have a background in essentially chemistry, and I'm really kind of a lab rat in the sense that I like working in the lab and I like making new types of materials. That word polymer is kind of another word for plastic. And so what we try and do in my lab is basically kind of redesign the typical plastics that you would use every day to try and make them have better end-of-life scenarios. So instead of just basically kind of the one-time use plastic dilemma that we have today, we're trying to figure out new ways to make plastics either disintegrate in our environment seamlessly, or to make them more recyclable in some way, shape, or form or another. And then on top of that, this new program that we are just starting, we got an award from the EPA to start this new program to help businesses transition to more sustainable packaging. And the EPA has a really huge database of products that we're going to use to basically help businesses come up with like a business plan essentially for how they use their one-time use packaging or other types of products, and how they can basically really bolster their image and attract new customers and really create a sustainability plan for their business that what we hope in the end makes them more successful as a business. But before I get to all of that, I kind of wanted to talk just a little bit about all the different types of plastics that are out there, and give a little mini course on basically what we're trying to transition to with our program. There's a lot of terms out there, and I know everyone's heard bioplastic before, but there's also biodegradable plastic, and then of course there's just recycled plastic. So the first key difference is that bio-based does not mean biodegradable. And this is something that many people are not aware of, that I wasn't aware of for many years. But just because something is bio-based does not mean it's biodegradable. So bioplastics, they come in many different shapes, sizes, forms. There's probably the biggest and well-known bioplastic is the plant bottle that Pepsi and Coke use. It's a partially bio-based plastic bottle that will not biodegrade any differently than any other type of plastic out there. So there's all sorts of different types of bioplastics. To be biodegradable, for something to disintegrate in soil, like you see in this picture in the middle, it has to be a very specific type of plastic. It's a very small subset of plastics that actually biodegrade in soil. So you see starch, cellulose acetate, that's like cellophane, old school cellophane. A lot of the stretch wrap we use now is not cellophane, but old school cellophane, so to speak, was biodegradable. And then all these other acronyms here, PBAT, PBS, PLA, PHA, these are just different types of plastics out there that do biodegrade. And these are less than 1% of 1% really of the plastics that are manufactured out there. I mean, it's a very, very small subset that actually biodegrade. Now, recycling is actually the EPA's recommended, and it's their top sort of choice for sustainable material. Recycling is probably one of the easiest end-of-life solutions for a plastic product because the process is basically to grind up the plastic, to melt it back down into pellets, and then those pellets can be used again to create new materials. The problem with recycled material is it's very hard to sort. When you put all your plastics at the curbside, which actually we don't have in Greenville anymore because they took that away. But even when you do if you do sort your own and you throw all your plastic waste in the plastic bins, that still has to be sorted into very specific types of plastic. So there's these big facilities called material recovery facilities, and they dump all of your waste, all the recyclable waste at least, into a very complex sorting machine. It's almost like it's a conveyor belt system. They first have to get rid of the paper, if you can imagine, all the paper and cardboard. Then they have to get rid of metals. Then they have to sort through the 9 different types of plastics. It's a very difficult process. And so that's what makes recycling really hard from an economic perspective. Is it's very hard to make money from recycled plastic because it's very hard to get pure plastic of a very certain type. And then when you do recycle it, that recycled plastic is typically not the same color. It's a little bit degraded, so it's not as good of a plastic. And so the cost associated with all of that is sometimes not worth it for companies, at least from a purely economic standpoint. It's not worth it because the cost between recycled plastic and first generation pure plastic is somewhat similar. So that's a big problem with recycling today is that whole process is very expensive. And we can see that for Greenville, it wasn't worth it enough for them to run that program anymore. They gave economic reasons. They said it's just too expensive to run it, and they weren't, I guess, able to make enough money off that process, so they got rid of it. I'm not supporting that in any shape or form, just saying that's the reasons that they gave. So if we look at recycling in a very large view, starting at this little pie graph, paper is actually the largest material that is recycled, and that's because it's the heaviest. One nice thing about plastic, you can say, it's definitely a beneficial component of plastic, is it's very, very light. So it typically takes up, not nearly the amount of weight of paper and cardboard and all those types of packaging materials. So you can see here the recycling tonnage over the past 60 years, most of it has been paper and paperboard, and relatively similar amounts of plastics, glass, and other things have been recycled. And then you can see how we fare in the rest of the world. We recycle about 35% of our waste, our municipal solid waste. So this is just everything that you would put in your trash can. When you include paper and glass, metals, plastic, the United States is about 35%, but you can see a lot of the European companies are much higher than that. Germany, especially, they have this green dot, there's this green dot program in Germany, which actually incentivizes a lot of companies to reclaim their plastic. And so they have a relatively high 65% rate. But it's just interesting to kind of see where we fare. And, really what this shows is it's not impossible to get higher recycling rates. It's just, there are many societal factors that go into recycling. It's really not just one thing that prevents us from being successful at recycling. So that's recycling. The next sort of major trend in plastic packaging is compostability. In fact, there's a study done by PMMI. They do a lot of surveys, and they found that compostable packaging was going to increase by almost 20% over the next 5 years, and really found that it was the one thing that companies are looking for nowadays, just because of that image and of the benefit that if it's possible for your plastic to go away very easily in soil or in compost, then that's a really nice way to get rid of your waste. The fact of the matter is, as we kind of talked about before, almost all compostable packaging is not home compostable. It's actually industry or commercial compostable. So that means if you see this BPI compostable sticker on your package, it has this little disclaimer here. It says commercially compostable only. Facilities may not exist in your area. So it means that, unfortunately, this will not degrade in your home compost. Commercial composting facilities get very hot. They're very highly regulated, and that's what allows the organisms to break down the plastic in those types of situations. There's another certification that you might see by the Compost Manufacturers Alliance. BPI is probably the industry leader in terms of certifying things compostable. The next one here is the CMA, or Compost Manufacturing Alliances. And what they do is they actually manually inspect to see how fast things biodegrade, just a different method that they use. So you might see that. And then the US actually does not have a certification for home composting. So companies now are using the European version, which is the TUV. So you see this OK Compost for home. So if you see that, then that does mean it can compost at in your backyard, essentially composting. But that's a European designation because we do not have one right now in the US. One of the main problems with composting is the lack of access. It's certainly, obviously, we don't have any curbside composting available where they'll pick it up and compost for you. I guess some of the yard waste they do in Greenville. I know there's a yard waste truck that comes around, and I'm not sure how they dispose of that waste. But one of the problems definitely is that there just aren't many of these facilities in places where there's high population density. I mean, California, Colorado, and some northeastern states have certainly a lot of facilities, but Midwestern states and southeastern states, we typically don't have certainly enough facilities to service everyone who would want to dispose of those. Now, these are facilities over 2,000 tons a year, so these are larger facilities. So there might be smaller facilities that exist in municipal areas, but this is from biocycle.net, really neat website that has a lot of these charts and graphs associated with composting and recycling. The other really problem is that a lot of these, even the industrial composters, don't like to take compostable packaging because of lookalikes. So you see here certified compostable materials, and those that aren't certified compostable look very similar. And so if you're a composter, if you're running a commercial composting operation and you want really rich, good compost to give to all of your customers, you don't want forks and knives and other types of paper hanging around in your product, because your compost is essentially the product that you're selling. And so this is a really big problem. A lot of compost companies just screen out every plastic they see. And so they end up screening out all the bio-based, or rather biodegradable materials as well. So that's another difficulty. So our sort of take, or our research at Clemson, sort of starts from these problems and starts with some of the grand challenges of plastic waste, and really tries to design new types of materials. And in the past, like I've mentioned, I've been interested in creating new types of foams, even, hard plastic materials, or even coatings like you see in these mason jars where right there, we're doing a water vapor test. We're seeing how much water vapor goes through that brown coating that we've painted. That's actually a paper sample that we were doing for a company. So we make all these different types of materials and we test them. And, that's what really motivates me. It's really exciting for me to make new things. I like to get in the lab. I like to work with my hands. I like to see physical results. But then we really began to think about, well, even if it's bio-based, it might not actually be biodegradable. So now we're really interested in looking at biodegradability and basically the result of soil health. So what's the effect to the soil when we do biodegrade these things in compost or other types of systems? So, there is a lot of different types of products out there that need redesign. A lot of these packaging products that you use every day have up to 7 different layers in them. And all those layers are different types of materials. You have a metal layer on the inside, which gives you your highest barrier performance. So that's really keeping out all the oxygen, all the water, everything else from making that product go bad. And then there's 6 other layers of plastic that protect that package. So how can we redesign that so that we can still maintain shelf life, but at the same time, that Doritos bag is not gonna, there's actually no end of life scenario for that. There's other than the landfill. So that's kind of difficult. So we want to design for biodegradation, and we also want to test. So a lot of companies have questions about, is this material really biodegradable, or what's this new product that we have? And unfortunately, what we're hearing from companies is there's just up to an 18-month wait time to get any kind of results back from biodegradability. So this area of research is so new that there's just not the capacity for all of these testing labs to do all these tests. And so by the time, you can think about a company that really wants to get an idea of what their material is doing, after 18 months, the market's changed, they've missed out. So we really wanted to make this a little bit more accessible to companies, both in terms of the testing and in terms of providing them assistance on transitioning to new packages. So this is what our lab looks like. It looks kind of like a snake of tubing here on the left. And what this is these are different chambers that hold compost, and we keep them in the middle sort of area here, these chambers for compost. And then we're measuring all the CO2 that's coming off of these. And that's a measure of how fast the bugs in the soil essentially are eating the plastic. So we measure CO2, and we have some other sophisticated equipment here to measure it electronically in terms of what's changing in the plastic, how is it biodegrading, all that kind of good stuff. So this is the kind of the work we do in the lab, but it's very difficult. It's very time consuming to measure biodegradation, and that's why it's not widely available to companies. In fact, I'll give you just a anecdote that when I looked at trying to get someone to test biodegradability for me before I had this system set up, it was $25,000 just for one sample to test biodegradability. So you can imagine if you need to test 10, 20, 30 samples, it's a very, very expensive thing. So we're hoping to make that more accessible to companies. Clemson also has, this is a real picture of Clemson's composting facility. Clemson also has a live waste stream where they take all the waste from the dining halls with the students. They take the game day waste from the tailgating experiences, and they have what's called a windrow system. So what these are piles that are kind of stacked up into a pyramid type shape. And what that does is it allows the gas, the hot air, to move up through the pile, and it kind of circulates the air better. And then they have different piles that are at different temperatures, and that these different temperatures, different bacteria thrive. And so those bacteria can eat and digest the different types of materials in there. And it takes about 6 to 8 weeks to create. If you can kind of look in the picture, as you go back, the soil becomes darker and darker. So it's becoming this rich black soil that my family's from Iowa, and they always bragging about how rich and dark their soil is. They have the best soil in the world, which I don't deny. But that's, you can see how the soil's getting, the compost is getting more rich as it goes on, and that's just the compost, going through its stages there. Oh, I see a question. I'm happy to take questions.
So I don't know if you'll circle back to this or not, but when you we're talking about the plastics biodegrading and you hear about things like, the plastic is broken down into like little particulate bits, but how much is there still like plastic that's kind of in the environment that, does it break all the way down? The ones that are considered truly biodegradable, are they breaking down into something that is then at the molecular level no longer a plastic?
Well, true biodegradable plastics, those have been certified, are supposed to be completely digested by bacteria. So
Okay.
they are not supposed to be making little bits of plastic.
Okay.
So a lot of the cups that you get, we'll say PLA on them, polylactic acid. That's probably 99% of the biodegradable material that we come in contact with. They have the green, I forget the name of the company. It's is it Eco something, but it's a green leaf, and if it says biodegradable on it, normally it's PLA, polylactic acid, and that's the name of the plastic. That is completely biodegradable. That's sort of the standard bearer. Yeah,
Okay.
so that can be eaten, completely up and consumed. The problem that you get into is when you blend plastics. So a lot of companies, they will blend like starch or glycerol. They'll blend things into normal plastics that the bugs already eat. So the bugs begin eating the starch that they blend in, and then they're hoping that it just the bugs kind of migrate over and also eat the other types of plastic. But there's a lot of research out there that shows that that's not really happening. What really happens is you break it into really tiny pieces that you can't see, but it's still microplastic essentially.
And that's what you're measuring when they say that they measure things and that they're finding like these compounds in the soil and things, would be something that was made from something that partially breaks down, and then the residual is what the bugs are like, there's other things, we can't break that down.
Right. That's why we have the lab-based system. So what the lab-based system allows us to do is we are able to say, okay, here's a 5-gram bit of plastic. That 5-gram bit of plastic should emit this much CO2 when the bugs eat it. And we are able to measure exactly how much CO2 comes off over the 90 days that we do the test. And so we're able to say, yep, the bugs ate it and they, digested 99.9% of that plastic, or we're able to say, nope, it, only about 50% of the CO2 came off that we expected to see. And so it really did degrade all the way. That's the advantage of the lab system. The disadvantage of the lab system is it's not a real compost pile. I mean, if you look at these piles, right, there's a lot, they're dynamic piles, right? They've got food waste, they've got plastic waste, they've got wood chips, they've got soil. So, I mean, it is, our process is much more, it's kind of under a microscope, but it does give you an idea of what's going to happen. And so it gives you some good information, but maybe not all the information. Yeah. The other problem with plastics and biodegrading is plastics have a lot of additives. They have colorants. They have things called plasticizers, which are components that make the plastic more flexible. They have UV stabilizers. There's a lot of different chemicals in plastics that then leach out when they biodegrade. And so those can be toxic. Those can be, a lot of them are what are called endocrine disruptors, which really mess with hormone activity. So in humans. So that's another part. It's just what kind of toxic additives are in the plastic.
Right.
Yeah.
Oh, thanks.
Yeah. Okay, so this is our composting. How are we doing on time here? Doing pretty good, right? Do I have all the way till 1, or maybe 5-10 minutes before for Q&A?
Yeah, if you leave some time for questions, and then we just need a few minutes at the end. So.
Okay, great.
Thanks.
So what does industrial composting look like? this is sort of an idea here. You see these piles, and typically what these piles have is they have like an exhaust system. So you're actually doing what's called reverse aeration. So you're filtering air through because you want to get oxygen through these piles. You don't want them to not have oxygen. That's when things tend to mold and tend to form other types of bacteria that aren't beneficial. So this is just an example of a commercial composting facility. And the reason why most plastics that are biodegradable have to be sent here is that it's just very highly controlled. The temperature is controlled, the moisture level is controlled, the oxygen level is controlled. And so that's why you really need this type of facility for compostable plastics. So that's a little introduction on all these different types of plastics and what our grant is really going to target. So now I'll kind of switch to talking about this new program. So the title of our grant that we submitted, or the title of our proposal that we submitted to the EPA, is Creating Change Through Education and Transition, Reducing Harmful Plastic Pollution in Disadvantaged Communities of Upstate South Carolina. So this was a proposal sent to the Pollution Prevention Division of the EPA, particularly in their Justice Through Environmental Action, I believe was the name of it. So we really do have to target disadvantaged communities. That's really one of the main goals of the grant. And our idea was, how can we reduce pollution by helping companies really transition to all these different types of products that the EPA has in their database. There's a lot of different databases and a lot of different products they have, but one of the big ones is the Safer Choice program. So you'll see this if you look on some of your products. This is mainly for cleaning products, healthcare products, home products. The Safer Choice really looks at the different chemicals, and you can get the Safer Choice designation if you meet certain criteria. We're more concerned about plastics, so we kind of delve a little bit deeper into what's called the BioPreferred catalog. And this is just a screenshot of their database online. And you can see there's all sorts of different categories, from baby, construction, custodial, films, and packaging, which we're really focused on. And if you go in here, you see all these different products, right? So you see a lot of these are just kind of the commercial names, so it may not make a whole lot of sense, but like, you know, Spudware high heat cutlery, different types of films for food preservation, sporks, what else? Portion cups, moisturizing hand wash, food grade greases, carpet care. So the problem is, if you sent a company here and said, hey, EPA's got this great website, why don't you get some renewable materials? They'd probably look at this and not really know what to do. And even if they did find something interesting, it's really not a holistic solution to you know, their needs in terms of packaging. So our idea is, how can we sort of digest, no pun intended, this this database and make basically a handbook that we can give companies and say, hey, you want you know, clamshells, you want to get away from styrofoam clamshells, here are your options, here's the cost, and here's what we think it will do in terms of your product image. You want cutlery, here are your, you know, here's some options there as well. And basically go through all the different types of plastic products that they use and try and give them some real world solutions for that. Have here just like, this is what we plan to do in the grant. We plan on making educational brochures. So we're looking at food service, food packaging, personal care. We're going to create educational curriculum. So we're going to create different modules, and these are going to be deployed at an organization called Mill Village. I don't know if you've heard of Mill Village Ministries, but they are in the west end of Greenville, and they're a nonprofit that really starts with education with kids and high school kids, and showing them how to, they really started on farms actually, and they'd have summer programs teaching kids how, basically teach them where their food comes from. And it's really been built up into a food share program. So they deliver, you know, thousands of pounds of food a week actually. And they also have a bike shop that kids can come and work their way into a bike, learn how to fix bikes and then gain their own bike through that work. And they also have a whole wing of their organization where they work with startups in the community. And they have a lot of sort of boot camps to teach these budding startups how to gain customers and develop their platform and all that kind of thing. So we're going to deploy a lot of our education through them. We're also going to have online webinars, basically because we know a lot of businesses aren't going to be able to come to the in-person workshops or educational modules. And then, yes, we will have workshops. So hopefully bigger opportunities where companies can come and get information. And then really some of the outputs that we're looking to give back to the APA, because what the EPA really wants is to know the outcomes. We're going to do case studies. We're going to do a case study webinar, case study workshops, really try and get all of this information out about what we've learned and some of the success stories and get it out into the community. All right, so now I'm going to give you our pitch. Okay, so this is our pitch that we are going to be giving to businesses. We gave this on a webinar a few weeks ago as part of Renew South Carolina. They are a sustainability focused organization. And so, that was sort of all the technical stuff behind what we do. But here's our image, right? We are the sustainable advantage. We're providing free P2 technical assistance, guidance to businesses with the goal of improving human and environmental health in disadvantaged communities. And here's our team. Dr. Hurley is the other professor here at Clemson working on this project. You might be familiar with him. He is the director of the packaging school. They had a storefront in downtown Greenville for a while, but he's a big name in the community for his work in the packaging school. And then we have staff from Mill Village. This is Cheryl Guaranero and Sean Peterson, and then 2 graduate students at Clemson that work, and they have really done all the work on this because they know how to use technology and we don't. And so that's Hunter Dixon and Margaret Alani. They've created all of these brochures, all of these, anything that looks good, they created. Margaret was her undergrad was in, forgetting the name of the program, graphic communications. So she really is able to design really nice brochures and PowerPoints for us. So again, here's the overview. We kind of mentioned this. We are looking to help businesses switch to eco-friendly packaging and products recommended by the EPA. And so here's all these different types of programs. And you might have seen some of these labels, but all of these labels are a part of the EPA program. This one, this USDA certified bio-based product, kind of towards the bottom here. This is one that I see a lot. The safer choice I've begun to see now that I'm looking. You can see the certified indoor air quality sometimes as you go around. But just take a look at some of your products after this presentation today. It's interesting how you'll begin to see some of these logos or stickers on the side of packages. We start with businesses by doing what's called a sustainability audit. So this is where businesses can either do this by themselves or they can have us come in and help them do it. What we'll do is we'll come in and just basically look at every product that they use. What are your waste streams? A lot of times we don't even know where our waste is coming from or what how we're using waste. And so we'll come in and help them do this. We'll also give you the worksheet to do it yourself. But this is really going to be the beginning to seeing where we can basically have some opportunity to recommend some newer types of products. Then after the audit, we really want companies to go through either the webinars or the course modules in person. And these will be kind of split up as either 30-minute webinars or the in-person portion. And the 3 courses are here. So the first is an introduction to the program. What is the EPA recommending? What do they offer? How can they help, right? And then our second course is when we're really going to go through that audit that the companies do and search for these safer alternatives. So this is really where we'll be using this handbook to hopefully give them more positive replacements and examples of packaging. And then finally, third part of the course is coming up with a business plan, coming up with how can you embrace these new products in your business? How can you deal with maybe some of the higher costs of these products? Because typically, these types of products are a little bit more expensive than the cheaper one-time use plastics. But we found certainly already ways that when you really think about your business, when companies think about what kind of materials they use, there's really a lot of reduction that can go on. You don't need to use as many materials a lot of times. And so sometimes we're able to switch to different types of materials, but use less, and we can save money that way. So here's some of the outcomes we will be really promoting for business. You receive this free sustainability audit. You understand the benefits of switching to eco-friendly packaging products. You determine which products are best for you, best aligned with your own sustainability goals, and then you generate and enact this plan to successfully replace those products with safer alternatives. So we have, as I mentioned, this QR code that we'll end the presentation with. And if you go to this code, it's a Google form where you can really give information. And this is where kind of an intake form for us, where businesses can basically get in touch with us, and we can get in touch with them and then help begin the process. You can also, if you'd like, you can certainly email me or Dr. Hurley, get more information about this program. If you know of anyone that might be interested, we'd be happy to talk with you. So yeah, that is the sustainable advantage.
That is great, James. Thank you so much. I am sitting here making little notes, like I need to go and read all of my packaging in the kitchen. I feel like I've been greenwashed in a lot of ways, but I'm going to start with the first question, and maybe if people have gotten your information, we can you can stop sharing so we can see everyone. But in the compost piles at Clemson, are they using an additive, or are they starting with a particular type of soil and blood meal and worms? And do you know?
Yeah,
about
they
that?
are. No, there's no, this is not vermicompost. So they're actually not using worms. And there are no additives. It's, they just control it with temperature and moisture. So, and they might mix in a little bit of, well, that's probably not true. Old compost, I was going to say, because old compost is, you kind of cure off all the bacteria, but no, so this is just straight compost.
I have a question.
Yeah.
Yes, that was really great. I thought I knew everything about the green world, but I have been introduced to a whole new field. Thank you for that.
Great.
I say that because I'm a LEED certified architect, retired, recently moved to South Carolina, and I'm just curious, do you interact with the U.S. Green Building Council or LEED certified buildings?
I have not. Some of those foams that we made, we had thought about getting in touch with those kinds of organizations because, with insulating foam and the way that it is used in these types of green buildings, but I have not had any contact with them.
Yeah, I just realized that the short-term use of materials versus the long-term in terms of buildings is really a major distinction. So yeah, I now realize that's a big deal, right?
Yeah, and in fact, they have been trying. There's been a lot of efforts to sort of recycle these one-time use foams into more durable foams that would, stay in a building for 60, 70, 80 years. That's kind of
Right.
one recycling solution.
Right.
So they don't just get thrown away.
Right.
So Dr. Sternberg, I was sitting here, I have a thought and then a question. The thought is, I think probably the most unfortunate aspect of the movie The Graduate had nothing to do with Mrs. Robinson, but was in that cocktail party when the fellow told Dustin I think it was Dustin Hoffman, right? He said, "Plastics, young man, plastics is the future." Now, not that plastics haven't done a lot of really good things for us, but the unintended consequences of, long term, I'm sure nobody back in the 60s gave it a thought. So, but my question is, having a forestry background, I was in the more the resource management, not so much the industrial end, but I was always told that there were, if not hundreds, thousands of products that came out, particularly of the paper and packaging industry. And my question to you, if you know, what percentage of all the byproducts of paper and packaging are beneficial in terms of the products that you're trying to promote? Or is it all just kind of the same chemicals that are a problem?
Do you mean like what percentage of wood-based products are sustainable or beneficial? Well, so here's the interesting thing. I mean, paper in itself is carbon neutral. You hear this word carbon neutral a lot. But paper comes from trees that are grown in a relatively natural life cycle, right? 10, 20 years. So all the carbon that comes from the trees and goes into the paper, no matter what happens to that paper, it's going to go back into the atmosphere and then go back into trees, right? So there is like a circular, the reason why paper is so kind of highly desired by the sustainability community is that it is carbon neutral in that sense. The reason why plastics are not is because all the carbon in plastic, if it's not bio-based, came from petroleum or oil, which was taken out of the ground. So now it's taken out of the ground and introduced into the atmosphere. So it's a net positive increase of carbon in the atmosphere. So paper has the benefit of, even if you burn paper, it's still carbon neutral because all of that carbon came from the atmosphere and is going back to the atmosphere. So it's carbon neutral. The tough part about, I mean, I don't know if you've ever been around a pulping plant, if you've driven down to Mount Pleasant, and driven over the bridge and smelled sulfur, is there's a lot of emissions from pulping plants. It's a nasty process to make paper. So there's a lot of emissions. So it's not like paper is completely innocent, right? It's, there's a lot of emissions associated with paper making. But on the whole, the products of paper are biodegradable. I mean, I bought some paper plates the other day, and it had a logo that I've never seen before, and I wanted to look it up, but it said home compostable on it. And I was like, well, if it's a paper plate, it probably is home compostable. Paper towels, right? I mean, there's a lot of chemicals involved in paper towel making, but now I'm beginning to see the compostability label for paper towels because they're seeing how important that is to them. So yeah, I mean, I don't know what the percentage is, but paper in a sense is not the biggest problem right now because, as you saw in the slide, it's also recyclable. So you can recycle paper too. And, as you saw over the last 60 years, almost 65% of what we've recycled has been paper. So there's better options available for paper than there is for plastic right now. And even if paper does get into the ocean, right, it's not going to last for 100 years and sink to the bottom of the ocean and affect all the plant life down there. It's going to degrade pretty quickly. So it's just, paper has the benefit of it's mostly cellulose, and cellulose likes to degrade. So it's just kind of has a better profile, so to speak.
Thank you. Yeah, that was good feedback.
Yeah.
Thank you. Any other questions or comments for Ken? Yeah, you're on mute.
Yes, I have talked to a lot of people in environmental issues over the years. And one of the classic questions I always ask is, if we were doing everything perfectly around the world, how long would it take for us to get the atmosphere back to a natural condition?
I don't know the answer to that question, but I do know we would have to like reverse directions essentially. because we're still producing more and more CO2 than we ever have before. So we haven't even begun to reduce the amount that we produce. We're still going in the wrong direction. So I don't know how long it would take. I think I've heard something around 100 years or something. But it would require a reversal of our current trend.
Yes, I asked an expert in sea level rise that question, and he said 200 years.
Okay. Yeah, I mean, it's an interesting sort of success story in this was the ozone hole. When I was going through grade school back in the 80s and 90s, that was the big problem. I remember hearing a lot about the ozone layer being depleted over the North and South Pole, or maybe it was just one of the poles, can't remember. But now the ozone hole is essentially patched. And so that has remedied itself over the span of a few decades, and that's because we stopped using CFCs for refrigerants, and we've come up with all these new products. I mean, I think the global, the amount of CO2 in the atmosphere is kind of a bigger problem because it's a global concentration. So, but I don't know, it's nice to have some positive information that, these things can change, and we could certainly get back to a better state, if we went the other direction.
Right.
Wow.
Thanks.
Good conversation, excellent presentation, and lots of food. No pun intended. Food for thought.
Good. Good.
It is distressing about those utensils because I do like to use the ones that appear to be good utensils when I'm getting fast food or whatever, but the lookalikes do create, I'm sure, a problem in the process. And so I understand why they end up getting tossed, which is really sad because I know there's a lot of work being done to create the bamboo and the whatever else they make those utensils.
Yeah. I'll say this as a sort of closing recommendation. The easiest and best thing that you can do to help the problem is do not put shopping bags in the recycling container. The paper or the plastic bags, plastic grocery bags are the #1 reason why recycling centers get shut down, because they get wrapped up all in their machinery. Those bags have to be brought back to the store to be recycled. And everything that I've heard is the #1 thing you can do to help the process. Just don't put your plastic bags. And that's funny because my kids do it. My wife does it sometimes. I have to be like, no, don't do that. Don't do, because it's so easy just to like, oh, I'm not going to throw this away. I'm going to put it in recycling, and that's better. But it's actually the main cause for shutdown at these facilities when they're trying to sort out the plastic. So
Yeah.
Yep.
Our community actually collects them, and then they go to treks when we've got like 600 towns or so, and we get a bench back. And but sooner or later we're going to run out of places to put all these benches.
All right.
Right. Savannah Lakes just got a bench.
A lot of it goes into new decking.
Right.
You can buy new decking.
Oh yeah, absolutely.
These new boards that they make. Yeah.
Okay. Well, one of the things that we do is every week, a couple of our members work on this, and they select a book, generally geared toward young people, that honors our speaker or program of the day. And this one was specifically selected for you, and it will be donated in your honor to a little free library in Upstate, South Carolina. And it's called What a Waste: Trash, Recycling, and Protecting Our Planet. And it's an informative educational book for children, and it uses fabulous illustrations and interesting facts about pollution and litter and renewable energy and plastic recycling. And the book includes many ideas for becoming a planet-defending hero. And so here it is March, but Earth Day is right around the corner, and I'm sure that this book will get some interest from young people. It's that time of year when we think more about these things. So thank you very much for that. One quick announcement. Oh, you bet. No, and we'd love to have you back sometime if you, particularly to hear maybe next year sometime after you've worked with the EPA grant for a bit. We'd love to hear more about how that story develops with that community.
Yep. Yeah, I'd be happy to be back.
Good, great, glad to
Yep.
hear.
Okay.
So next week we have Taryn Cadena, who actually spoke with us last year when she was a global scholar, Rotary scholar over in the UK, and she got a job with the Monterey Bay Aquarium, and she's going to be giving us an update via video. Julia is going to host that program, and we're going to see what she's up to out in California. So she's a really remarkable young person. She's called a life aquarist out there, working with all the various critters, and looking forward to that program. So I hope you'll come back. That one will be at 6 p.m. As you know, April 2nd, we will be going to all noon programs. So you won't have to figure out what week it is to join our meetings. So all that said, what we do end up with is reciting the four-way test together. So if you would unmute, please, and we'll say together the four-way test of the things we think, say, or do. First, is it
the truth?
second?
Is it fair to all concerned?
Third, will
Will
it
it
build?
build goodwill and better friendships?
And fourth, will
Will
it
it be
be
beneficial to all concerned?
Well, have a wonderful day, everybody. Great to see everybody. And thank you again for that wonderful program. Really appreciate you being here. And Bill, good to see you. I will be following up with you.
Awesome.